A United States Gerald R. Ford-class nuclear supercarrier costs roughly $13 billion to build. It represents the absolute peak of heavy military engineering. A single 1-gigawatt artificial intelligence data center campus requires a $38 billion capital investment, nearly triple the cost of that carrier. At this scale, these facilities are the heaviest industrial machines on Earth. When developers plug these operations into the open public grid, the local system fractures. In states like New Jersey, residential utility rates have jumped nearly 20% over the last 2 years. This spike is driven by grid operators scrambling to reinforce public transmission lines to handle the massive new AI load. Instead of the tech companies footing the bill for their own energy requirements, the financial weight is shifted onto the public ratepayer, acting as a hidden tax on working families. The engineering failure starts at the 100-megawatt line. A typical modern office building draws roughly 1 or 2 megawatts of power. A 100-megawatt data center draws enough continuous electricity to sustain a city of 100,000 homes. The standard public grid cannot absorb that kind of localized drain. When a developer applies for power, regional operators like PJM force the project into a multi-year interconnection queue to study whether the new facility will trigger cascading multi-state blackouts. Currently, that delay averages 5.2 years, leading to a nearly 80% project failure rate. Because high-performance AI processing chips become obsolete in 3 to 5 years, a 5-year wait for a power permit makes the multi-billion-dollar hardware investment worthless before it ever boots up. Citing hyperscale computing on standard electrical wires is a failure of physical engineering. The public network was never designed for this density. To fix this, state planners are shifting the geography of the industry. New mandates require developers to build their data centers directly at the source, the primary energy generation plant. Through generation netting, the data center hooks directly into the power plant's generator behind the utility meter. Electricity is consumed locally without touching the public grid. Placing no stress on regional wires, this bypasses multi-year stability studies, completing safety reviews in just 10 months. Moving the facility a few hundred yards directly behind the utility meter instantly neutralizes the AI industry's greatest regulatory hurdle. But physical proximity is only half the solution. To insulate the public ratepayer, local utilities enforce a take-or-pay mandate. Tech developers must sign 15-year contracts where they are billed for at least 85% of their capacity, regardless of whether their servers are running. Second, developers are required to post aggressive upfront capacity collateral. Before a shovel hits the dirt, they must lock in $1.5 million for every single megawatt of requested grid support. For a standard 100-megawatt facility, the developer hands over $150 million in liquid cash or irrevocable letters of credit on day one. This creates an absolute economic firewall. The infrastructure is paid for in full by the tech company, isolating speculative industrial debt from the public utilities balance sheet. What happens if the AI market shifts and a tech giant abandons a massive 100-megawatt data center shell? The sovereign receivership clause handles this scenario. Under the zoning permit, if an operator walks away for 90 consecutive days, the physical property title automatically detaches from the bankrupt corporation. While creditors can remove the mobile AI processing chips, the permanent body, the heavy concrete shell, the internal cooling manifolds, and the substations are seized and transferred debt-free to a state utility trust. Because the upfront collateral already cleared the construction debt, the state inherits a turnkey industrial asset. They can lease the space to public supercomputing hubs, ensuring the site remains active at zero cost to the residential ratepayer. Mandating power plant co-location forces us to confront the generation sites themselves. Building next to a nuclear plant means building near spent nuclear fuel. Because the federal government never finalized a permanent national waste repository, every commercial facility stores spent fuel rods on site on massive concrete pads. The waste is sealed inside dry storage casks, engineered with stainless steel canisters and 3 feet of high-density concrete. They require zero electricity, relying on natural convection air loops to continuously vent heat. These installations are globally standardized, highly managed engineering realities. They do not prevent commercial development from operating safely on the surrounding land. Adjacent co-location solves this. Building inside the high-security perimeter requires multi-billion-dollar blast bunkers. Moving the data center just outside the security gate simplifies engineering, while remaining close enough to run private power cables directly across the property line behind the meter. This proximity enables a shared industrial water cooling cycle. Standard data centers vent thermal energy into the atmosphere and evaporate millions of gallons of water just to stay cool. By contrast, co-location pipes that 110-degree waste heat directly into the power plant's feed water intake, reducing the fuel needed to generate steam and increasing the plant's net electrical output. Plugging hyperscale data centers into the open public grid is an obsolete parasitic practice. By forcing these loads into mandatory co-location, we stop the cycle of residential rate hikes and reclaim thermal energy that would otherwise be wasted. It is the only framework that secures the public grid.